Okay, this lesson is on the complex zero over polynomial. We are trying to combine the knowledge we had from previous lessons where there's complex numbers and there's real zeros. So let's start with the fact that we have real zeros, right? So first example here, we have the real zeros of x equals 3, x equals negative 5. So x equals 3, x equals negative 5, and negative 1/2. Rewriting them into factor form, right? So x minus your zeros. And then this additional information, this is a key information. The additional information of that extra point of negative 116 will allow you to solve for the a, the coefficient in the front. All right. So first, let's write them as factored form of the function. So you have your a, you have x minus 3, x plus 5. Now, that 1/2, that negative 1/2, it may take a little bit of manipulation to see, but you need to rewrite it so that it looks like 2x plus 1. The best way to do this is to work backwards and see what you would get when you solve for 2x plus 1. All right. Now that you have these, you want to plug in your given value of negative 116. So 16 is your y value, your x value is your negative 1. So we plug it in and then we clean up as much as we can to get our a. So we combine our numbers, negative 1 minus 3, negative 1 plus 5, 2 times negative 1 plus 1. So you get really eventually 16 equals 16a. So you solve a equals 1. Then in this case, we don't really need the a because a is 1. So your final answer for this function is going to be x minus 3 times x plus 5 times 2x plus 1. Now, you have to make sure you read the direction. It does say that we want this in factored form. So if it's in factor form, your job is done. You don't need to multiply this whole thing out. If it wants it in standard form, make sure you do multiply it out so that you get your highest power all the way line down to the lowest power. Okay, remember conjugate pairs. If a complex number is a 0, then its conjugate is also a 0. So that a plus bi and a minus bi still works here. And don't forget, we have that awesome formula, right, for our ax squared plus bx plus c. So if you recall, ax squared plus bx plus c, your b is simply the first conjugate minus plus the second conjugate and subtract them, right? So it's the first conjugate plus the second conjugate added together and the negative value of that. And your c value is multiplying the two conjugate pairs together, right? So you're multiplying them together. So using this to write your factored form, all right? So here we have the first one. Our very first, it does say in factor form, so we don't need to multiply it out. Our very first 0 is x equals 1. So from the x equals 1, I can write the first factor of x minus 1. 5i, you have a couple ways to do this, but I remind myself 5i really has a plus or minus 5i, and I know that came from x squared plus 25. You can still use the formula we did above, but I believe that's more useful for the next one where you have 1 plus I. So keep in mind if 1 plus I is your 0, then 1 minus I must be the other 0. Right? And so using our formula of b equals the two conjugates added up, and don't forget it's a negative 2, not a positive 2, and c is the two conjugates multiplied together to get a positive 2. So finally, our function is going to be, well, this conjugate pair is going to give us x squared minus 2x plus 2. All right, now we're going to combine all three parentheses to get a final answer of our function in factored form of x minus 1 times x squared plus 25, and then x squared minus 2x plus 2. Okay, you should be really happy we're not asking you to multiply this out. This would be kind of a pain to multiply out. Okay, continue the idea here. We have x equals 1 and then 1 again. So what this is trying to tell you is that there is a multiplicity part here. So with these two combined, you have x minus 1 twice, so you have x minus 1 squared. You don't need to multiply it out. This is factor form, so leave it as x minus 1 squared. Reminding yourself you have negative 4 plus I, so negative 4 minus I must be your other conjugate pair. So here you have your other pair using the formula again. So you have b equals that b, when you add these two terms up, you'll get negative 8, but don't forget it's the opposite of that, so it's going to be positive 8. C is a product of these two, so you will get the total of 17. So your factor for this one is going to be x squared plus 8x plus 17. And of course, finally putting that together, this is your factor form of the function. Okay, that's it for this lesson.